Montana State University's been doing research on sawfly, wheat stem sawfly, for more than 100 years.
Economically, the sawfly is spreading. It's an unusual insect.
It is a small wasp-like bug that shows up for just 3 to 4 days in its flying season and ends up invading the stem of the wheat plant.
The adults lay eggs into the stem when that wheat is almost ripe. Sawfly then prepares to spend the winter down about an inch below the soil. It goes down the stem into the crown of the plant. And as it exits, it cuts a ring around the stem close to the ground to essentially make a spit wad and plug the stem above it. When it makes that spit wad, it takes enough material out of the stem to make it very weak there.
It cuts the stem off and the wheat plant falls on the ground, and it's very difficult to pick up.
And it's frustrating because you have a beautiful stand of wheat, and because of the way the biology of the sawfly is, as the combine is rolling, the stems are falling over.
The problem with sawfly, more than anything else, is the sheer devaluing crop impact that this pest creates. On a low-price crop in, say, 2023, Montana's losses were estimated by growers to be $65 million. But on better price years, those losses would be averaging $91 million.
We can go out in the field in the spring and see sawflies flying around like crazy, but we don't really know what the extent of the problem is until the end of the season when it's too late.
It's a genetically diverse organism also, can adapt to some diversity in the host.
There's always a next step with wheat stem sawfly. It's pretty hard, so as an insect pest.
We've dealt with this problem pretty much longer than anybody else. And so we're here as kind of that foundation to provide other states and farmers around the region with solutions that have already been investigated here.
When we started doing this project, we didn't even know exactly the status of wheat stem sawfly. It wasn't called wheat stem sawfly, it was actually called western grass stem sawfly. And all the entomologists said, well, this is going to be a problem if it ever starts using wheat. The first real damaging populations in Montana were in 1910.
When agriculture came to the state in the form of small grains, wheat especially, and primarily spring wheat, because of the very harsh winters that we had back then, that the wheat stem sawfly moved. It had this, hey, I'll move over to this Garden of Eden, if you will, this huge wheat field where very nutritious, right, for the wheat stem sawfly.
As time passed, they adapted so that they were able to also use the acres that were planted to winter wheat. But they had to adjust their biology, basically. There's a famous paper by my predecessor, Wendell Morrill, where he points out that the sawflies adapted a month earlier so they could use winter wheat and complete their life cycle before harvest. So that was winter wheat. That was in the 1970s. So spring wheat, 1910, winter wheat, 1970s. The adult females only live a very short time. They don't have to travel very far to lay eggs. They don't lay very many eggs, but once that egg is inside a stem, it's pretty safe. Not much will kill it. You can't spray insecticide and kill them. Most systemic insecticides won't kill them. The only ones that might are so toxic nobody wants to use them.
I think David, Phil, or Luther would probably tell you how devoted Montana farmers were to finding a solution to sawfly in those early days. While guys had tolerated it for a century, it had always just been a nagging hangnail. But then came a shift. Maybe it was the terrible drought through the 80s where this pest had no nutrition from its traditional grasses. Maybe it was the enormous saturation of CRP. We don't really know for sure. But it seemed like overnight, sawfly became a common theme at the coffee shop. Producers raised big red flags, and that enthusiasm caused Montana State to pivot.
I was hired in July 1st, 1992, and at the end of that week I was up in Conrad and Havre looking at wheat that was damaged by wheat stem sawfly. So So I got an early look at it. Coming here to be a plant breeder at Montana and then having to tackle the sawfly problem was, in my previous position, I never felt like I was really needed. I did a good job. I developed varieties. But here, there was a huge need for development of winter wheat cultivars that would work better against wheat stem sawfly.
At the time, there was a Department of Entomology here on campus. The department head recognized a need. There were a lot of, he had an extension role, so there were a lot of extension questions about wheat stem sawfly. And he brought me in as someone to start working on sawfly. As a result of that, we started presenting this information on, well, there are these things you can do. We need host plant resistance to be better. We started making those kinds of presentations, and then the grain growers came in. I think the guy's name was, in fact, I know his name was Randy Johnson, and he came by and said, you know, what do we need to do about sawfly? And the answer was the one that you always get from researchers, or you get from anyone who's facing a problem. What was it? Yeah, we probably need an infusion of cash to try and build a program to work on wheat stem sawfly.
Like most wheat commissions, the Montana Wheat and Barley Committee spends a great majority of its investment on research. Our organization has invested somewhere north of $1 million just on sawfly since those early days in the 90s researching the pest. Producers are using every tool in their toolkit to mitigate sawfly. Some swathe, some purchase stripper headers, some are betting on parasitoids to help solve the issue, and nearly everyone is planting one solid stem variety or another.
I have swath in this. It's a preemptive strike to put it in a row that I can pick up with the machinery I have. It makes harvest really long. It costs money, takes resources. It's not a satisfactory solution, but worse than that, on the science side of things, the parasitoids that feed on these sawfly, which we're trying to increase, suffer at the hands of a swather because they need to finish out their life cycle with that sawfly larva. And if the larvae are above your cutter bar, you've not only killed that sawfly, but you've killed the parasitoids, which we're trying to propagate and get more of.
Along with that adaptation of the sawfly in the landscape, one of the most important things, which figures into this prominently, is the fact that not only was there the sawfly in the grassland, but there are also populations of things that naturally regulate sawflies. We call these parasitoids. They kill sawflies. They actually are very important in our wheat fields.
Parasitoid is a small wasp. They parasitize other insects. The adult wasp will sting through the stem when the little larva of the wheat stem sawfly is feeding, will sting it, paralyze it, and then lay its egg right next to or on the wheat stem sawfly larva. The little wasp larva will feed on and devour the wheat stem sawfly larva. A challenge is how do we enhance those parasitoids in terms of increasing their populations so that they make a bigger hit. They reduce more the population of wheat stem sawflies. With the parasitoids, it's really managing the farm, the landscape, the ag production system such that we encourage those populations of parasitoids. So that takes time, and in some years the populations might be low and you wouldn't have as much impact. In other years, populations will be high and there will be an impact of those parasitoids on the wheat stem sawfly populations.
Well, this is a 42-foot stripper header. It's a shell-borne. And what happens is that you'd have a wheat head, so we'd have that shield a little bit higher, but the wheat head would just come here and get bent, and this rotor turns really fast at about 500 RPM. And so when that wheat head comes like this, it gets actually stripped and flung across this shield.
Why use a stripper header?
It has an advantage on Sawfly as far as we can pick up, actually where we have Sawfly, we can pick up pretty good as long as it's not flat on the ground. But it also favors the parasitoids to basically overwinter and survive. So hopefully
in
with
your
that,
stubble.
in the stubble,
This is
yeah,
bad. Okay.
in the stubble.
We've planted mostly solid stem wheat because we have a problem with the wheat stem sawfly. All of the solid stem varieties came from a variety that was developed back in the 1930s called Rescue. And the genetics for all the varieties we have now came from that variety called Rescue.
There wasn't any winter wheat solid stem varieties, so the first big thing was the couple years before I came, breeding lines were put together. We crossed, or they crossed spring wheat with our best winter wheats to get us started. So we had some populations, and what we had was loose spring wheat crossed the Tiber, and that was essentially the basis of our winter wheat solid stem varieties, because that's all we had at the time. It takes 8 or 10 years from when we make a new cross until potentially we could release it as a variety. So we had all this intermediate research going on, but the first thing we did was we released Rampart, which is actually a sister line to Vanguard, but it was a little better. It was had the same parents, but it had different production advantages. We demonstrated that we increased yield of both of them, but that gap from the very beginning was always kind of maintained. So a similar yield gain every generation, both in the solid stem and hollow stem, but of course we started a lot later with the solid stem materials.
The problem with solid stem varieties is they have an inherent yield drag. They yield about 5 bushels an acre lower, or maybe even more than some of the hollow stem varieties. Even though it yields less than some of the hollow stem varieties, the loss you suffer from the sawflies and the hollow stem varieties can be greater than the yield loss that you get from the solid stem.
Through breeding, especially in the spring wheat breeding program, we're seeing that gap between yield and sawfly resistance seems to be narrowing. And so just through selection, a lot of testing. So we do statewide yield trials where we hope some of those yield trials are also getting infested by sawfly. And we test in hundreds of lines in these yield trials. And so what we're doing is we're looking for that one golden line out there that has the combination of high yield, high sawfly resistance, and shooting for excellent India's quality.
Our spring wheat breeders and our winter wheat breeders make high horsepower solid stem varieties now. Yield incredibly close to hollow stem, not quite, but very close. And these things are way tougher than Rescue, but we still have sawfly cutting in that at some level. It's not immune in any way.
The Montana State University team that works on sawfly cuts across. It's not just entomologists, right? It's wheat breeders and agronomists and others. So we have a very broad team, and that's really important.
Over time, consistently, creating new populations and going through the breeding process, we're continually stacking those positive alleles together, and we're improving sawfly resistance, yield, while trying to improve India's quality, or at least maintain it, and and then produce a variety that has the characteristics that meets the requirements for our farmers, end users, bakers, and so forth.
We now have other university researchers now involved, which is great. We don't wish this problem on other states with wheat stem sawfly, but because that's their reality now, we have all these new thoughts and additional brain power to help solve this problem, which is very exciting. And so for all that to happen, we need coordination across states, and we need kind of long-term investment strategies because this problem is expanding and spreading.
The breeders in each one of these institutions, whether it's Montana, whether it's Colorado, whether it's Nebraska, whether it's Kansas, all these programs are slowly understanding that we have to work together, and we are coming together actually. And we have had discussions into bringing in not only exchanging germplasm among ourselves, but exchanging breeding materials among ourselves so that we can test it better.
What I'm most interested for the future of sawfly research, one, I'd say in the past year or so, I've noticed that there's more attention given to sawfly, especially as it's become a problem in places like Colorado and Nebraska, sending more resources at it. And, you know, as I mentioned before, the team aspect of people from different disciplines, I think is really exciting.
So we are going through, germplasm from around the world, trying to find new sources of resistance. So what we do initially is we'll take those lines that we get from other countries, other places in the world, we'll put them out in the field in areas where there's high sawfly pressure, and then they'll grow through the growing season. Hopefully they get infested by sawfly. If we see signs of resistance, we'll then take that line and then start doing some genetic research on those materials that we get from other countries. So the next step from there is we'll cross what we think might be a resistant line to a Montana adapted susceptible line. And from that cross, we get populations that we can then use to identify the location in the genome of where these resistance genes are. When we find that, then we go ahead and start crossing that into the breeding program to start pyramiding with the genes we already have in there to improve resistance.
My first exposure to sawfly was in trying to understand the resistance of wheat, and we actually created that map that identified specific loci that added to resistance, mainly related to stem solidness, but not totally related to stem solidness. But it's the stem solidness trait that we've been taking advantage of. Through this grant that I'm on with Weaver and Jason Cook, it's a USDA NEFA grant that is actually funding this map. And so we've got this family that is a cross between Kraft and Hockett, and hopefully it's segregating for its ability to withstand sawfly. And the way a genetic bank works is you put the family all out there, and then you see this line got infested, or this line, they died, whatever is happening, and then you relate that to these genetic markers. We've already had the population genotype, so what we do is we run like 50,000 genetic markers on this population, and then we look for recombination events essentially between those genetic markers, and then that will help us to correlate the sawfly resistance to a specific part of the genome. And so hopefully within the year, we're going to actually have genome regions that we think are involved in being resistant to the wheat stem sawfly and barley.
I'd say that we've covered as many aspects of wheat stem sawfly as I can think of to do. I mean, we've done pathogens that may kill sawflies in outbreaks in the field, biological control with parasitoids, host plant resistance, how it works, how a female sawfly uses odors to find the wheat plant and choose to lay an egg in the stem. All those kinds of things we've been working on. Based on some questions from Greg Carlson, who was a former Northern Ag Research Center superintendent who is no longer with us. He asked me, he said, there's this variety, Conan, and it doesn't get cut very much, but it's not very solid. Can you tell me what's going on? turns out Conan doesn't produce as much attractant compound as some other wheat varieties. So if there's one, like a small plot nursery, that's more attractive and one that's less attractive, they move away from the Conan to the one that they like better. Then we were also doing some observations in the lab. Mostly very good staff I have said, you know, we're looking at this Conan early on here, because we would collect samples when it's green still, and it's incredibly solid. And I said, well, no, it's not. It's not supposed to be. Turns out they were right. It is very, very solid when the sawflies are flying. The pith disappears. This phenomena, we presented it to Luther Talbert. It's called early solidness. It's a new mechanism whereby maybe, and I can't speak to this too much, but we're always concerned about yield. So maybe breeders can make a solid stem variety that's solid when the flies are flying, and then gives up that pith that might boost yield a little more, because the nutrients that were going into pith can be resorbed and used for head weight.
I don't know of anybody else who's working on small molecule profiles and things like that, but I think it would be interesting to look at some of the cultivars that other states and other universities have and are using to combat the problem, just to see if we're seeing the same kind of responses in those cultivars that we see with ours. So just because our solid stem cultivars react a certain way, it'd be interesting to know if that happens in other environments as well.
If we find something that is non-solid stem based resistance, then there is immense hope that we find hollow stem lines that will just prevent the insect from drilling in, basically. Anything that can prevent the insect from drilling into the plants, or there is something that the plant is producing by itself, like they say in oats, it produces a sap, which prevents it from laying eggs and prevents eggs from hatching, etc. So if something like that comes forward, then yes, we will have a hollow stem winter wheat.
So oat was kind of our jumping off point in that it has the complete resistance, and we were really excited to see that, because we want to know, can we either transfer this to wheat, or is there something similar in cultivars of wheat that we can find? So by doing those comparisons with infested and uninfested plants, we were able to see in wheat to a lesser extent some of those same compounds. The next step was then to figure out, in lines of wheat that are similar to the ones that we looked at, is this something that happens in all wheat? We were started on the path, but we're not near figuring out exactly what's causing that resistance or transferring that to wheat, unfortunately.
We use sensors that capture a lot of that light that's not in the visible spectrum, and it can tell us a lot about the plant physiology. So ultimately what we're trying to do is we're trying to go out to a field, we're trying to grab a small number of samples, and then we're trying to grab imagery in the most efficient way possible and turn around an accurate infestation map. So that's the essence of what we're working towards. So what this work results in is essentially a map of the field we've been studying. And it's going to kind of look like a heat map. So we're going to see areas of low infestation and areas of high infestation. The sawfly, usually it's an edge effect creature where we're seeing the heaviest infestation adjacent to those sources of sawfly populations. But with more of this work, we are starting to reveal some of the nuance in how these patterns distribute themselves across the field. So essentially, you're going to see a map of your field, areas of low infestation, areas of high infestation. With remote sensing, a lot of people put a lot of emphasis on that word remote. And so, some people ask me, well, you can do this here, can you then take that model and use it in North Dakota or Colorado? Remote sensing requires some information of what you're trying to estimate on the ground. And so to do this work, we still need to have information each year from the locations we're studying.
With wheat stem sawfly and research that is so important to provide the evidence in which then we can make management recommendations, we definitely need long-term investment, because this is, like I keep mentioning, a wicked problem. It's nothing that can be solved easily.
Integrated pest management approach is what's going to be needed to really deal with the pest. Entomology, they gain a excellent understanding of the life cycle of sawfly, their behavior out in the fields. There's a lot of things we don't know, is like, why one year a variety seems resistant, but then the next year the variety just falls flat on its face, it's totally susceptible.
Management of sawfly really needs to focus on a holistic, comprehensive approach because, again, it has to do with the environment, it has to do with the sawfly itself, the plants and their level of resistance, as well as the natural enemies that exist in the form of mostly the bracconid parasitoids here in Montana.
I do believe that the expansion will continue, especially into these winter wheat and spring wheat areas. It just begs for regional cooperation and leadership when it comes to weed stem sawfly from Montana State University.
The more people we can get involved with it, the more possibility there is for avenues of a positive direction in sawfly management.
The thing about this organism is it's pretty smart. Everything is constantly evolving. So anything we put out there, eventually there's a possibility the organism will evolve to overcome it. There's always a new threat. There's always a new problem to address. And that's just the way life works.
I think there's enough positive feedback from all of our research that we can effectively manage what right now seems to be unmanageable and a wicked problem. But I think there's enough to be positive about going forward.
We need every institution out there to help to stop the wheat stem sawfly. It's now confirmed in 4 other states. It's moving into barley. It's just a matter of time before all of our wheat states are affected. The more we can collaborate and research, the more we can share stories. We don't want to reinvent the wheel for the last 30 years of research that Montana State has worked so diligently toward. We want to make sure that you have this information to be able to move forward in the fight against sawfly. Sawfly is not just a heartbreaker, it's a farm breaker.